Hi all, so welcome to this channel, and in this video session I'll discuss option list properties for an SQL procedure. So let me tell you, I have already created a video on option list for the SQL functions, which you can refer from my channel videos. I'll give you the link on the top right corner of this video. You can get that from here. So let's start with the explanation of all these points, all these properties which SQL procedure inherits. So let me tell you first thing, that is language SQL. So default for an SQL stored procedure. If in a stored procedure which is different than SQL, that is let's say that's an external and that is based on the let's say on RPGL program, then we need to use this, or we need to write this statement language, then that language RPGL or C, whatever you are using. It is an optional statement, so if it's an SQL stored procedure, so no need to write this. Move on to the second point, that is specific name. So specific is something, so we have two things in the stored procedure. First one is the stored procedure name in itself, and then the specific name. So specific name is something you can say which is an system name or a short name, and the stored procedure name can be a long name. It can be short or a long name. So if you define a stored procedure and there are multiple procedures with the same name and the same schema, then how do you identify that? Then specific keyword comes into the picture, and you can give it a unique name, unique system name for that stored procedures that have the same names. So every stored procedure, even that have the same names, must have the unique specific name. So that plays a part in creating the object name as well. So whatever the specific name, that would be the object name on the IBM I. So object name means the program name. So if we do not specify the specific, then the system in itself uses that word and create a unique name for you. So let me show you here. So you can see this is an procedure name and this is a specific name. So you will find the object with the specific name. So this must be unique for every procedure. So if you have this name procedure with n number of times, then every procedure have the unique specific name. And one more thing to mention here is, if you specify create or replace and you are changing the name, so in that case, so you cannot change the name in that case, else if you change the name, it would create a different procedure for you. So it's a default clause. If you want, you can use this. If you do not want, that the system in itself use this. So I prefer that I prefer to use this always, because then I have a control on the specific name, else I don't have a control on the specific name. And when I drop any procedure, if they have the same name, then this plays a vital role there. We can drop a procedure using the specific name. Now deterministic and or non-deterministic. So again, these two are the optional one. This one is also optional. If you do not specify, not deterministic is activated, and if you specify, then you can specify both of them. But if this is default and optional, so if you do not specify, not deterministic will be used. So what does these two means? So basically, whenever we call an SQL stored procedure with different parameters, let's say an SQL procedure is having only one parameter, and I'm passing that with value 1 or 2. So whenever I pass with 1, I would get some result which is either let's say that's dynamic, which is fetching from some table, and that's dynamic. And if I pass with 2, I'll get some other result. So if I pass 2 again, then what would be the result, whether it is deterministic or not deterministic. So as I already told that is dynamic, so it must be not deterministic. And if it is static, so whenever I pass 2, I'll get the same result. So then I can code deterministic in that SQL procedure. If I do not have any idea whether it is static or dynamic, then I would prefer to use not deterministic. And not deterministic is something which is default, so we do not need to code this. This is an optional and default. So basically what happens here, whenever we call a procedure with some parameter, that saves in the cache memory, and if deterministic is used there, then the procedure then won't get called again. It basically fetches the result from the cache memory first in case of deterministic. Modifies SQL data. So modifies SQL data is default, so every SQL procedure is modifying the data, insert, update or delete things works, so it is default and optional keyword. Called on null input, again this is default and optional keyword. So if you want, you can specify. If you do not want, you cannot. You must not specify. You don't need to specify these two, because these are default and optionals. So you can pass the null values to the parameters of the SQL procedures. Dynamic result sets, integer. So basically this is something I have just created a video on result set, where I am returning the result sets one or multiple, or receiving or retrieving the result sets one or multiple in the caller or from the call procedure. So you can watch these two videos here, and let me tell you what actually it means. So whenever we create a procedure, it either returns a 0 or maximum up to 32768 result sets. So there are several procedures which are called from the caller, and they return the result sets, and they can be consumed in the caller. So, and there are several which do not returns anything, any result set. So the default here is 0, dynamic result sets 0, and then we can code it also dynamic result set 0 in the stored procedure if we do not returning anything, just because whenever we have some cursors declared and they are opened, they must be closed, or the commitment control things, whatever defines there, must be committed or rollback. So all these things must be happened when we define this. So must be occurred before the called procedure returns to the caller. So this is an optional again. If you do not specify, the default is 0. And the next thing is disallow, allow and disable debug mode. So this is related with the debug capabilities of an SQL procedure, so we can use them to disallow or disable the debug properties, or allow the debug properties. Fetch and not fetch, so this is ignored by the SQL procedure thing, but this is used in the SQL functions. So let me tell you, not fetch is something when your procedure is running in the same thread of the caller, and fetch is something when your procedure is running in the separate thread from the caller. That is an overhead actually. So this is basically ignored, so though we don't need to talk about this. Program type main and program type sub. This is something which I have not discussed yet, because I have not created any video on the external procedures. So I'll create the videos very soon on the external procedure, external SQL functions. And now this is something whenever we call a program from the external procedure, then we use program type main. Whenever we call a service program procedure, we use the program type sub. So this is the difference here. And one can say that in case of C, one can say it creates a type, it creates a program type object, or it creates a service program type objects in case of procedures, because as we know that when we have the SQL functions, they created the service program and a procedure gets created inside that, and in case of procedures, program gets created actually whenever SQL procedures are created. old save point level and new save point level. So let me tell you this thing. This property is something, let's say we have a caller and a call procedure, okay, and save point is something, as we know, they are transactions. Transactions mean, which is, transaction is something which is preferred as a unit. So there are several things happening within a transaction. So update, insert, delete, everything is happening within a single transaction. And let's say I'm taking an example of the transferring the amount. So whenever I transfer some amount from one account to another, so a credit has to be happen into the transferred account, or transferring from account, debit has to be happened. So these two actions has to be performed separate, independently, and they both are actually called one transaction. Okay, so if I would say that the debit, I would take something like debit happened from my account, then I actually save the save point. So at this point, save point 1, let's say, is created, so which have the image of the debit happened from my account, and then I called a separate procedure which actually credited the account amount onto the others transferred account, and that is in the, let's say, in the other call procedure. And then we would say that have the separate save point. So let me tell you what is old save point level and what is new save point level. So whenever you have a caller and you have a call, so this is the this is what I explained, the save point. Now if you create a save point in the caller, then that is called an old save point level. So you have created the save point 1 in the caller, that is called an old save point level, and then you just call the called program or procedure. So whenever you create the save point in the called one, you will call that the new save point level. So basically that would take the same name as the old save point level. But in the old save point level, as in the caller, if you are creating multiple save point, then all the save points must be different, or you can say must be unique. But here in the new save point level, you can use the name of the caller one. So that's the difference between these two. And next property is commit on return with, okay, commit on return is the next property. So we can mention this in our SQL procedure just whenever we are using the commitment control thing. So let's say we are calling we are calling some procedure from an caller, and that updates some transaction, some tables, like, okay, that performs a transaction, you can say. And then if that update is happened or that transaction is successful, then what happens? Then commitment control has to be happened, commit has to be happened, because we are using the commitment control. The data should be in the data integrity should be maintained in the system. So in that case, a commit has to be happened. So we basically write commit on return in the called one. So the call procedure must commit all the things whenever you return to the caller. And if, let's say, if any error occurs, what happened? If you define that SQL update thing within a begin atomic thing, then automatically it rollbacks to the original state, or okay, and if, or you can roll back to the original state. So, and one more important thing here is whenever you define the cursor, so let's say you define the cursor and you want to use the result set of that cursor in some caller one. Okay, so what happened? You committed in the call one and you want to use the result on the caller one, and now once you committed everything, the cursor gets closed. Okay, but you want to use the result set of that cursor. How you do that in the caller? So you need to create the cursor with the withhold feature. So whenever you use withhold keyword with the cursor, whenever you are declaring cursor, Then you can use a result set, which is transform the cursor into the caller one even the commit has been happened already onto the called procedure. So that's the difference. That is the use of the commit on return. Autonomous autonomous is something which is used by the SQL procedures, so that let me tell you, we basically use the activation groups. Okay, so when we use the autonomous, what happened if certain procedures are running in the default activation group, so they don't interfere with the procedure which is running with the autonomous keyword. Let's say if we want that a stored procedure must run in some specific activation group which is explicitly defined, then we must use the autonomous, so that it must not interfere with the ones which are actually running in the default activation group. So that's the thing here. Now concurrent access resolution. Concurrent access resolution is something used whenever we are running the concurrency thing in the SQL procedures. So there are three things: default, which is default, wait for outcome, use currently committed. So default is something whenever we are not using the concurrent access resolution, and wait for outcome. So let's say we are committing something and the update is happening. Update is happened and we are committing that update. So when that commit on the update is happening, at the same time should we wait for outcome? So if we use this option, it would wait till the time commit is not happened, then it would use the certain features, or it performs certain actions after that. So if we use currently committed image, and what happens, whatever the currently committed image is, then that would be used in the table, that would be used during that processing. So if in case a commit is happening but it's still not happened fully, so whatever the currently committed image was, that would be used with the process. So that's the thing here. Next thing is set option statement. So there are several options which we can set, that is debug view. So we can first set the debug view thing, which is optional, star none, star source, star statement, star list. So we can specify this for debugging the SQL procedures. DFTRDBCOL, DYNDFTCOL. So basically DFTRDBCOL is used to set the schema name. So if in case we have not used the library qualified library name with the table, so we can specify any schema name which we want to refer, or dynamic DYNDFTCOL is, or we can use yes or no with this one. So if it is specified as yes, then whatever the schema name mentioned here would be used with the dynamic statements as well. So if you have any dynamic statements in the SQL procedure, then that would basically use the schema name which is defined on the DFTRDBCOL, else if you define no, it won't use that. Now DIN user profile. DIN user profile is something whenever you are calling an SQL procedure from the client, let's say from Java, let's say, and what happened there, a procedure must have the authority, okay, and either it would have a user authority or it would have an owner authority. So whenever you call that, so you must specify, you can specify this DIN user profile, that is either owner or user. If it's allow the user to run, you can use the user. If it's have the owner authority, then you must use owner, so that you would be able to use the run that stored procedure. Now the next thing is extend. Extend is something which you can set using the set option. Even the naming convention you can set */ or *SQL. So as I mentioned at the last, extend is something extended indicators you can use in the SQL procedures. If you can specify *yes or *no for using this or for not using this. So whenever you are updating or inserting any column in the tables using this stored procedure, you can use these extended procedures, extended indicators in the SQL. So if you use indicator 0, value is 0, then that means set the current value. If it's -1, then set the null value to the column. If it's -5, set to the default value of the column. If it's -7, then ignore that column during insert or update. So these are the things which we must consider, or which we can code during SQL procedure. So as you can see here, I have not used all of them. I have used create procedure, then this, and one property that is specific here. Let's say the next one. Here also you can see I used only one thing. Here you can see, let's see the next one. So here you can see I have used language SQL. This is optional, as you can see, and this is also optional. Here use these ones. You can see here I use result set thing. So yes, we can use all these things in the SQL procedures whenever we are coding the SQL procedures. So that's all option list properties for an SQL procedure. So that's all. Thank you and have a nice time.